Hello everyone and welcome back to another video. Now this video is one of the most important videos of the Linux Masterclass course because in this video we are going to talk about the user management as well as the permissions, how these things works in the Linux ecosystem. And if let's say you're planning to become a sysadmin or a system administrator, or you're planning to take a role in DevOps field, maybe an AWS developer or something like that, if you're planning to do anything of that sort, then this video is extremely essential for you. So do make sure to watch this video till the very end. This video is the third video of the Linux Masterclass course, and in front of my screen you can see the playlist, the Linux Masterclass courses playlist, and it contains about 3 videos, where the first video was just about installation, and then there were 2 videos about the basics of Linux, and here you can also see all the timestamps that were there in the last video. So if you haven't watched that yet, then do make sure to watch that out. And without any further ado, let's get started. Now when you run any process, it will always run as the owner of that process, right? And listen to this carefully, because this is something that we are going to come back to at the very end of this video. So pay attention. Whenever you run a process, it always runs as the owner of that process. Whatever files we have in our system, their access and ownership are also sort of permission dependent, right? So if let's say we have two users, if let's say I have two users, the first user is Apoorv, right, and the second user is Kunal, right. So these are the two users. Now Apoorv in any case cannot access any of the files that belong to Kunal, right, in the same system. And every user has their own home directory where that particular user specific files are stored, right. So we, like, up until in this course, we have already seen many a times my home directory. I'll again show it to you. If I pwd here, and this is like the, like when the terminal opens up. So if I see here, I see a specific path which is simply known as /Apoorv and /Apoorv. So this means that there is a user on the system known as Apoorv, and this is the uh, path of the specific files of Apoorv user, right. So if let's say I had another user in the system, if let's say I had a user named Kunal, then there would be a specific directory for Kunal called /home/Kunal. Now in my current system, the username is pretty simple, right? It's simply my name. It's Apoorv and then Goyal, right? But this is simply the username of my user, right. But the system has another set of ID, which is generally known as UID, which is the user ID, right. And this is the user ID that the system uses to identify a user, right. The username, which is Apoorv in my case, is simply an easier way of identifying a user for us humans, right. But the system, the Linux system, uses this UID, the user ID, right. The system also uses groups to manage permissions, right. The system also uses groups to manage permissions, and these groups are simply just a set of users with similar permissions. So imagine this scenario that you have a server, you have a system, and in that system, let's say there are 3 different types of people who use that system. Maybe there are some web developers, right. There might be some DevOps guys, and there might be some people who might be doing something related to database DBMS stuff, right. So now if let's say that there are about 3 web developers that access the system, there are about 2 DevOps guys that access the system, and there's one DBMS guy. So I can simply create groups for these users, right? I can create certain groups for web developers, I can create certain groups for DevOps guys, I can create certain groups for DBMS guys, right? And I can grant these groups some permissions which would also be, applicable to the specific users of that groups, right? So that's where, groups usually come in handy to, categorize different people into, different categories based on, whatever work they have with the system, to grant permissions accordingly, right? And we'll talk about, these permissions and everything later on in this video, and then it would all start making a lot of sense, right? So let's not delve more into that at this point of time, but just know that just like, different users have UID, the user ID, to identify, different users, different groups have GID, right, which is the group ID, and this group ID is used by the system to identify a particular group. It might be that web developers might be having a group ID of 1, DevOps might be having a group ID of 2, and DBMS guys might be having a group ID of 3, right? So just basic stuff. Now Linux also has some users in addition to the humans that are using the system. So in the current scenario, I am the only human who uses this system, Apoorv Goyal. So this system only has one user right now with my name, Apoorv Goyal. But it's not like I am the only user in the system. There are more users other than me in this system. Right. Now these users could be system daemons, right? The processes that make sure that everything is running smoothly in the system, and they are the ones who are responsible for making sure that all the processes are running continuously and seamlessly, things like that, right? So these users could be anything. There might be that some users are responsible for showing you the GUI of this entire system, things like that. So there would be different uh, users for different purposes, right? And we'll take a look at all of these users again in some time. But there's one user which is the most powerful in the system and the most important in the system, and that user is known as the root, right? Or the super user. Right. And if you are, let's say, familiar with Linux, then you must be already knowing about root and super user. Right. So root is the most important as well as the most powerful user in any Linux system. It can access any file in the system, and it can also, start or terminate any process in the entire system. Now there are some files in the system that we usually as normal users cannot access. So let's take a look at that. I'll open my terminal now and simply write a command cat and then /etc /shadow, right? If I press enter, it simply says that permission denied. Why? Because me as a regular user, I do not have the sufficient permissions to view this file, right? And if I, let's say, do an ls-l to like check the detailed version of this file in my system and press enter, I would see that this file belongs to the root user, right? The user which is the most powerful, right? So there's a simple command in terminal, right, which gives you the root access, and it is known as the sudo command, right? And the sudo simply stands for super user do, right? So su of the super user and then do. This is called sudo, right? So we have a sudo command, and if, let's say, now I want to access that same file, then I can simply do a sudo and then cat and then /etc and then /shadow, right? If this time I press enter, it is going to ask me for my password, because root user always asks for your password, right? I press my password, I press enter, and I can see that this long file has opened up for me with so much content. Now it's not a good practice to always use the sudo command, because if you, let's say, always have the root privileges with you, then you might end up deleting some system critical files that will crash your system ultimately, right? So use it only when you need it. And since we already know that sudo is the command to access something as a root user, there might be some time where you want to stay as the root user, although it is not recommended. But if it is the case, if you want to stay as a root user, then there is a simple command known as sudo and then su, which means superuser do sudo and then su, which is again super user, right? So it will simply make you a super user. I press enter and now I can see that I'm the root user of my system, right, inside my home directory. And now I can do anything. If let's say now I try to do that cat slash etc and slash shadow and I press enter without any permissions error, I am directly getting the contents of that file, because now I am a super user. Although this is not recommended to do, so don't do this no matter what, right? And to quit, getting back to a normal user, you can simply type the quit command. Sorry, you can simply type the exit command if you want to get back to being a normal user, right? So that is there. And some of the downsides of being root user, as you already know, is that you might end up making some critical mistake that might crash your system. And secondly, whatever commands you execute, they they don't register in the history. So just to show you an example, if let's say I press the up arrow key, I can see that the last command I used was sudo su. So after becoming a sudo user, if I let's say do an ls and if I let's say do a pwd, right, and I simply exited from here, right, and now I check my history, right, I can see that the last command it registered was sudo su before history. Although I still executed the ls as well as the pwd command, but it is not registering that in my history, right? So you won't have access to whatever commands you executed as a super user, and you might end up making some mistake that will crash your system. So it's not recommended due to that reason. And if you really want to have some root privileges, or access something as a root user, then just stick to sudo, right? Don't go with this. I just told you this because uh, it's good to know, right? But try to avoid using this. Now, as you know, when I say that running anything as a root user or a super user, it's kind of dangerous. Then also giving everyone the access of using the sudo command is also dangerous, right? So if we just try to ask this question, that who are those people who can use the sudo command, then the answer is very simple, right? I can simply view a file which is known as sudoers, right? So this is a file in the slash etc folder, slash etc slash sudoers, right? Simple file. If I press enter, it says permission denied, obviously, because I'm not used sudo, right? But if I press sudo and press enter, I can see that it gives me a list of all the people who are able to you know use the sudo command, right? I can add some names into it. I can delete some names. If let's say I have a user called Kunal in my system and I don't want Kunal to you know access the sudo command, I can simply remove him from this list, right? So that's how it goes. Now remember when I said that I am not the only user in the system and there are a lot of other users as well. So who are these users, right? Like, what are they doing in my system? If let's say there are more users that are there in this Linux system apart from me, then what are they doing? We know that root is one user and I am one user, so who are these other users? So there's a simple file. Again, I'll use the sudo command, and what I'll do a sudo and then cat, and then I'll do a slash etc and then a slash passwd, right? So this is one file which contains data for all the users that are there. And if I press enter here, then I can see that there are a lot of users in my system. So root is one user, and then daemon is another user, and we'll study about what these daemons are and processes are and things like that, so don't worry about that. And you would again see that there are some there is an nvidia persist something persistence user, right? And this, as I imagine, might be responsible for all the GUI stuff that is happening. There's some speech dispatcher and things like that. So there are a lot of these users who are responsible for different things. Maybe games would be the one who is responsible for running any game in the system, and then mail and news might be responsible, as the name suggests, for emails and news, regular updates and things like that, right? So these are all the users. But and you can also see that I am also here, right? So I am also a part of the system. Apoorv Goyal is the user that I am currently. But let's try to understand what this actually means, right? This entire text that is there in front of me. So what I'll do is I'll simply just take this text and paste it here. uh, Try to increase the size of it, right? So now this kind of looks good, right? And let's try to give it some numbers for better understanding. So let's say this is 1, this x is 2, this 0 is 3, this 0 is 4, then this root is 5, and then this is 6, and then this is 7, right? So it has about 7 parts to it, right? Separated by a colon, right? These two dots are known as colon, right? So let's say this is the breakdown. Now I can easily say that the first thing that is there is simply my username, right? So for the root user, the username simply is root, and for me it is going to be Apoorv Goyal, right? Now then, as the second value, there is an x, right? And this is generally the password for the user, right? So it is simply the password, the second value. And by looking at the second value, you can if let's say the value of it is x per se, then this simply means that the password is stored in another file known as /etc/shadow. We are going to talk about that file after this, but let's just stick to this file for now. So x simply means that your password is stored in a file called shadow, right? And again, I mean, for a Apoorv Goyal user as well, value for the second value is x, right? So that is there. Now coming to the third value, the third value is simply the user id, right? Whatever user id I have. So username is different and user id is different. User id is the one that is used to you know for by the system to identify a user, and as you can see, root by default has 0 user id, right? And fourth is the group id. So it's simply the group id. Now if we talk about the fifth one, fifth is generally just a comment about the user. It could be that it could be the full name of the user, it could be things like their contact details or something like that, right? So just some user info, right? Nothing special about it. The sixth one is a user's home directory, right? So it is the home directory of the user. And the seventh one that is there is simply the user's shell, right? So this is the shell. Now there are different types of shells, right? There is that ZSH, there is fish, there is bash, right? So it simply tells you what shell the user is, right? And in case of user, it is /bin/bash, right? For my user as well, it is /bin/bash, right? And for some users, it is non-existent, right? As you can see. So, or for some users, it is no login, right? Something which requires no login, right? So that is there. there are going to be different shells, and this might differ from different distributions of Linux, although most of the distributions uses bash by default, but it might be different for different users. So that was all about the /etc/passwd file, which simply tells you about different users and their user IDs and things like that. And here in the password, we also mentioned that if the value is x, that simply means that the password is stored in /etc/shadow file, right? And this is the file that we also tried to access earlier, right, when we were learning about the sudo command. So let's take a look at this file right here. What I'm going to do is I'm going to clear my window and then try to open that file, cat and then /etc/shadow, right? I press enter and I see again a lot of data, with some data for root and some data for me as well, my user, right? But let's just study the root data, right? So I'll quickly take this text, I'll copy this, again I'll paste it here as a text, try to increase its size, right? So again, to number all of this stuff, let's say that this is my 1, this exclamation mark is my 2, this is my 3, right? This 0 is my 4, this 999 something is my 5, and then this 7 is my 6, and then I have about 3 more things which could be my 7, 8 and 9, which are simply empty, right? For root. And in that case, I mean for all the users that are there, and we'll know why it is empty when I'll tell you what they are. But again, if we talk about the first one, then this is simply the username, right? The second one is the encrypted password of that user. So earlier it was X, which simply meant that the password is there in /etc/shadow, and now here it is the encrypted password, right? So in case of root, we can notice that it's simply an exclamation marks, which kind of means that root takes the password of the current user who is using the system. And in case of Apoorv, when we can simply see that it is this big string, which is sort of an encrypted password. My password is pretty small, 5 letter, but since it is encrypted, it is this big hexanumerical string sort of a thing, right? So that is there for the second part of it. Now if we talk about the third part of it, and this is quite interesting, right? So the third is the date of last password change, right? So this is like the date of the last password change. And now you might be wondering that this number 19108, this doesn't kind of resembles like a date, right? So what exactly is this number? So this number denotes the date, but it denotes it in a sense that this is like the days since 1st Jan 1970. So that's how it maintains date. So when I say that my third value for the root is 1910.8, then it simply means that since 1st January 1980, 19,108 days have passed when I last changed my password. Right. So I mean, I'm still not sure why it is this, like maintaining a date in this format where it is simply date since 1st January 1970, but this is what it is, right? And the fourth value in this, which is simply a 0, is the minimum password age. So this simply means that I have to wait about 0 days after which I can change my password. Now, some systems might be configured in a sense that they don't want you to regularly change your password, right? They want you to stick to your password for, let's say, about 30 days or a month, and then you can change your password. So in that case, if let's say this value, this 0, this fourth value would have been 30, then that would have meant that I have to wait for 30 days before I can change my password, right? So that is there. And again, I mean, when I, let's say, try to change my password, it would simply check that if the current number of days that have passed since 1st January 1970, if that number is greater than this number plus this number, then I can change my password, right? So that's how it should work logically, as far as I can think, right? The fifth number is the opposite of the fourth one, max password age, right? So this is like the maximum time when you can have this password. Some highly protected system might expect you to change your password every month, right? And add a new password. So then this 99,999 would have been just 30, right? And it would mean that after 30 days have passed, you have to change your password. You cannot just uh, access root with the same password that you had, but you have to change your password, right? So that is there. And if we now talk about the sixth value that is there, then sixth value simply means the warning period for the password. So about 7 days before it is about to expire, it will start warning you that, bro, change your password, what are you doing, man, right? So it will start warning you, right? भाई पासवर्ड चेंज कर ले. Right. And now we see this 7, 8 and 9, which are simply empty, but they also have some value, some meaning to them, right? So 7 simply means the password expiry period. It's like how many days have passed since your password has expired. So for the root user, currently this field is empty because the maximum period is 99,999 days. Those number of days has not passed since this password has been set, obviously, right? Because I'm not sure if anyone would be alive for that period, and if the earth would exist for that long, right? And or it might be that we might have settled in Mars or something. But anyways, getting back to the topic, since my password has not expired yet, right? Then why would it have any value, right? So that's why it is empty. But it simply means the expiry period of the password, like how many days has passed since it has expired. Then 8 means account expiration date, that on what date your account will expire, right? It might be that as a system administrator, you want to give someone access for just a limited period of time. You say that, okay, you only have access to the system for 3 days, right? Or 30 days, right? So you can set this number for that particular user. Again, if I go back to my terminal, I can see that for even for my user, the Apoorv Goyal user, those last three fields are empty, right? But if I, let's say, wanted to have this user to only have 3 days, I could have set this value to simply 3, right? And then it would mean that from the time this account has been created per se, right, I only have 3 days. So if the current date is, let's say, 19,111, 112, then I don't have access to my account anymore. It has expired, right? So as a sysadmin, you might have to expire some accounts. You can do it through this, right? And the ninth value is somewhat of a reserved field, right? So the devs of the Linux community, they still haven't been able to figure out what would exactly go in the ninth field, but sometime in the future when they do, they are going to start using this field, right? So they already have an extra field for keeping in mind that it might someday come into some use. कभी ना कभी तो काम आ ही जाएगा. In most of the distros in today's point of time, the authentication somewhat doesn't depend on this, only depend on this slash etc slash shadow file, but in the modern ecosystem there is another system known as the PAM, right? The PAM. If you are an Office fan, then you might know who PAM is, but ये वो वाली PAM नहीं है. This is not that PAM, right? This is simply a pluggable authentication. For a second, I forgot the spelling there. And module, right? Excuse me for looking down again and again because I tend to create some notes while teaching so that I don't forget anything, right? So I like to refer there so that I don't actually forget anything while teaching, but that is there, right? So PAM is the more recent authentication system that some distros have started implementing, but I think it doesn't comes by default. You can read more about it online in some blog or something. uh, but yeah, that's pretty much it. And there is one more file known as sudo, my caps lock, sudo slash etc slash what was it, sorry, I forgot the cat, right? So slash etc slash group, I think it was group. Yeah. So this is like one more file. This is simply to maintain the data of group, right? Now since we have already done the what these things means for all the files above, let's do it for this one as well. You can see that there is one known as Apoorv Goyal as well, and there's one more and one more, right? uh, but we'll like it will start making sense to you soon when I talk told tell you about this, right? So again, let's distribute it into simple stuff: first, second, third, and then fourth, right? So if I talk about the first one is the group name, right? If I talk to you about the second one is the group password. And there's generally no use for password for groups, right? But if it is, then you can add an encrypted password here, right? So for the entire group, so that was there for the password, right? Now the third field, which is 0 in this case, is the group ID or the GID, not the CID, right? The GID. And the fourth one that is there is simply the list of users in that group, right? So here, wherever you are seeing my name Apoorv Goyal here, then it simply means that I am a group of that user. I am a user of that group. Right? So, and if let's say a particular group has more than one user, then these users are separated by a comma, right? So for admin, the syslog and Apoorv Goyal, both of us are users, right? But for cd-rom only I am the user, for sudo only I am the user, for dip only I am the user, right? For plugdev and lp admin and lxd and samba share was like a software I was trying to use to share my screen, but wasn't able to use that. forgot to uninstall. But yeah, that's pretty much it for the files, the important files that are there in the system, maintaining all this data for you. Now we, saw, so much about the users and groups and things like that. How do we create a user, right? So for that, there's very simple command known as sudo and then useradd and then a name, right? So let's say I want to create a user with the name of Kunal. I can simply do sudo useradd and then Kunal, right? This very simple command. As the name suggests, it adds a user. It will automatically create the directory slash home slash Kunal in my system, and would create, all the files that Kunal may be needing for himself. And whenever, I'll turn my system on again after switching it off, I'll see two users. Which one do I want to log into? Right. And the same things applies into Windows as well. As you might have seen in Windows 2, you can have different users. There is something known as guest users in Windows as well, right? So this simply creates a new user for me, and it will, you know create that directory slash home slash Kunal. It will also automatically create the entries for me in slash etc slash shadow and then slash etc slash passwd and slash etc slash group, all the files that we just saw, right? So it will easily, automatically create modify all those files for me, as well as create whatever is necessary for Kunal to start using the system, right? So as simple as that. If let's say on the other hand I want to delete a user, right? So to delete a user, I can simply do sudo and then del and then Kunal. So just how I created a user, I would delete the user. I'm currently not creating a user, right? But just for your knowledge, you can simply use the useradd command and userdel command to add a user or delete a user, and it will simply, change everything in the system. I mean, just how the add user command or the user add command, uh, yeah, the user add command, just how the user add commands, creates all the things in your system, the user del command would undo all of that, right? So it will delete all the home directory and, unmodify the files that it earlier modified for, in the slash etc slash shadow and passwd and group and things like that, right? So it will handle everything for you. And if you, let's say, want to change your password for some reason, then there's one command known as passwd, right? Passwd will help you change your password, and I can simply, add the name of the user I want to change the password for, right, after this. So if let's say I want to update the password for some user, maybe their password is about to expire or something, their maximum password limit instead of 99,999 was 30 or something, or 10 or 1, whatever it is. Maybe they need to change their password daily, and they didn't come to office someday, and you as the system admin have to change their password, passwd, right? I can simply do sudo passwd passwd and then Apoorv Goyal. I press enter and it will ask me for a new password, right? It says bad password, but obviously I don't want to change my password, and it will not let me terminate this. So what I'm going to do is I'm going to close the terminal. It is going to ask me if I want to close my terminal. Obviously I want to do, and I'm going to open a new terminal, right? As simple as that. And here you one new change that you might notice would be that my host name has suddenly changed to Apoorv slash hyphen Goyal, right? So this is my host name, the real host name, but since I like to keep my Twitter handle here, and you can also change it, then to do that you can simply do sudo host name and then the name that you want to keep as your host name. For me, it's my Twitter handle, Apoorv Tweets. If you haven't followed me yet, go follow now. Right, pause this video and follow now. I'll not move forward until you follow me. Right, I press enter. It is going to ask me some password, and it has changed. Now you will see it is the same, but don't worry. I close this. I open a new one, and I can see that now this time it is Apoorv Tweets. Right. So that's how it goes, and let's move forward. Now that was all about the user management, but now let's talk about permissions, right? So before we get started with permissions, let me quickly run a command, right? So I'll quickly do an ls-l, right, on my home directory, and if I press enter, again I can see all this stuff, right? So I can see, these few things that are mentioned for all the directories that I have generally in my home directory, and here I can see that the first thing that is mentioned here, this thing we are going to talk about in a lot more detail, but this that we have here is the username of whom the this directory belongs to, who owns the directory, what is the user that owns the directory. This is the group name, like what is the group that owns this directory, right? And this might be the last modification time of the directory, right? So this is how it usually is, but we often see, whenever we do hyphen ls hyphen l, whenever we run that command, we often see this thing in front of us. So let's try to understand what this actually is, right? So what I'll do is I'll quickly copy this, and I'll paste it here, right, as a text. So now it is pasted. Let's increase the size, and this looks good, right? So this is the general text that we usually have, and if we look closely to it, then we can see that this generally, yeah, we can see that this generally has about 10 bits, 10 characters, or we can also say that this has around 10 bits, right? And these bits that we are talking about, these are specifically the permission bits of that particular directory, and even the files have some permission bit, right? So if I, let's say, quickly create a file test.txt, right, and I do the same thing, then I can see that even the directory that even the the file that I just created is also going to have some permission bits to it, right? So it has these 10 bits that are meant for permission, we understood that, but what does this actually mean, right? So it has about 4 parts to it. Let me break this down for you. So the first part is the d, that is there, the very first character, right? The second part that is there is the r w x, that is there here, right? And the third part is again an r w x, right? And then we have a fourth part which is an which is a r hyphen x, right? So we have these 4 parts, and again let's number this. So this is 1, this is 2, this is 3, and this is 4, right? So we have these 4 parts. Now let's talk about these parts, like what do they represent, right? So the first part that is there, it generally tells you about the type of whatever it is. So in type, D usually stands for a directory, as you might have guessed. And even here, I mean, all the directories that I have, they start with D, right? But for the file that I have, this test.txt, this file, this starts with a hyphen, right? So all the files that are there, they are usually represented by a hyphen. So whenever it is a hyphen, it simply means that it's a file. And there is one third type as well that you cannot see in like the example that I showed you, but that is an L, right? And L is simply for a link, right? We'll study about links in a lot more detail in some other video later on, but for now let's just understand that there's something known as links, right? So we have a directory, we have a hyphen which is for a file, and then we have L which is for link. These can be the only 3 types, and now we have these three bits, the second part, the third part, and the fourth part, right? So we have these 3 bits. So what is this second part? This is generally the user permissions, right? Like what sort of permissions does the user have on a particular file or a directory or a link, right? The third one is the group permissions. And the fourth one are other permissions. Right. So this is what it generally is. And if you look at it, this is just one bit, right? These are 3 bits, these are 3 bits, and these are 3 bits, right? So in total, they accumulate to what? They accumulate to 10 bits, right? And that's what it usually is, right? So now we understand what the type bit is, and we can see that the second part that is here, this is usually for the user permissions, this is for the group permissions. Now there can be multiple users in a system, right? If let's say I am currently the user with the name of Apoorv Goyal, there might be another user in my system, let's say with the name of Kunal, right? Or there are other, inbuilt users as well in this entire system, such as root and some other users that we just saw earlier in this video, right? So all the other users that are there apart from me itself comes under the other part, right? So here in this example you can see that all these things are currently owned by the user Apoorv Goyal, right? All of these directories and files are currently owned by Apoorv Goyal. So if any other user apart from Apoorv or root, because root is the most powerful user, but if any other user apart from you know me or root tries to access these files, then they would have these permissions, these last 3 bits, right? And now even in the bits we can see 4 different characters. So there is one R, there is one W, there is one X, and there is one hyphen, right? So R is the permission for readability, right? W is the permission for writability, it makes a file writable, right? And X is for executable. And if somewhere it is empty, I mean it has a hyphen, then it simply means that this permission is empty, like no permission is granted for this particular thing. And the general format that is there is always represented by the readability, writability, and executability, right? So the general format that we have is always going to be readability or readable, and then we have writable, and then we have executable. So if let's say the first one out of the 3 bits is a hyphen, then this generally means that the user does not have the readability, like the access to read a file or a directory. If this is hyphen, then it simply means that the user does not have access to write it, right? And if this is a hyphen, that it generally means that it does not usually have the access to execute it, right? So in the above example, we can see that the user have all the 3 you know privileges. They can read, write, and execute. The group of that user also has all the 3 privileges. They can read, write, and execute. But any other user can only read and execute, but they cannot write to it, right? And similarly, if we take a look at this one, which is for what, which is for a file, right? Then this here we can see that it is a file. The user has the reading and the writing ability, but not the execution, right? The user cannot execute it. The group can read and write it, but cannot execute it. And any other user apart from the current user, the owner, or the root user can just read it. They cannot write to it, they cannot execute it, right? So this is generally what it means. And these RW, X, and hyphen, these are symbolic representations of the permissions. So each and every file in Linux generally has all these permissions, and based on that it is decided what user can do what with uh, certain things, certain files or directories, right? And since we are talking about symbolic representations, let's also take a look at the symbolic representations of the users, groups, as well as others. So as you might have guessed, users are symbolically represented by U, groups are symbolically represented by a G, and others are symbolically represented by an O, right? So this is pretty simple, straightforward stuff. Now let's take an example of how we can modify these permissions, right? If let's say we want to change the permissions. So I'll quickly remove the file that I just created and go to the bootcamp directory, and here what I'm going to do is I'm going to create a file and a file, right? I'm going to create a file known as testing.txt, and I can see that the file is created, right? So by default this file has the read and write permissions for user, read and write permissions for group, and just read permissions for any other user, right? Now let's say I wanted to change its permissions. So to change its permissions, there is a simple command known as chmod, right? So chmod is what? Change or modify the file, right? And after this what I can do is, if let's say I want to add the the writing permission for any other user, right? I want any other user to be able to write to this file, right? So for that what I'm going to do is I'm going to do an O, which symbolically represents others, right? And I'm going to do a plus. Plus generally means that I want to add some permission to the others, right? And then I'm going to do a W, which means that I want to give the right like the right permissions to this all the other users, right? So that I'm going to do, and then I'm going to write the name of the file, right? If I press enter to this and again do -l, right, then I'll see that earlier which was r hyphen hyphen is now rw hyphen, right? So now I know that I've added, like, successfully given the right permissions to any other user who will try to access this file, right? So again coming here, we can say that the plus symbol represents to add permission, or is used to add a permission, and the minus symbol is generally used to remove permissions, right? So that way you can simply change permissions. If I want to, let's say, remove permissions, then I would have simply done a hyphen or a minus, and if I again press enter, do I like ls hyphen l, then I can see that my right permissions are now gone out of this file. Now let's say that you wanted to add multiple permissions for a file, or you wanted to give one permission to multiple types of users, right? So in that case what will happen? If let's say that I wanted to strip off all the permissions from all the users, right? So I can simply do a chmod. Now I know my users are represented by a U, groups are represented by a G, and others are represented by an O, right? So I'll write chmod and then ugo, then I'll do a minus, right? And I want to take off the read, write, and execution permissions out of them, right? So I'll simply do a r, w, and x, right? And then I'll write the name of the file. With this way I would have removed all the permissions from the file. So if I now, let's say, do an hyphen ls hyphen l, then I'll see that there are no permissions to these files, not for the user, not for the group, and not for any other user, right? Again, in a similar manner, I could have just added all the permissions. If I press enter and then again do an ls hyphen l, then I'll see that now everyone has all the permissions, right? So this was all about permissions and how you change permissions. But there's another way to change permissions, right? So just let's take a look at that. Now we already know that the read, write, and execute has some symbolic representations, right? The readability is defined by R, the writability is defined by W, and the executability is defined by an X, right? But they are also represented numerically through some numbers, right? So if we talk about the readability or the readable permission, and we talk about the writable permission, and we talk about the executable permission. So this readable permission that is there, it was represented by R, this was represented by W, and this was represented by an X, but this is also represented by a 4, this is also represented by a 2, and this is also represented by a 1, right? So now let's say that I remove this file and again create a file. So I do a ls-l and now let's say that in this file I want to grant all the permissions, the read, write and execute permissions, uh, you know, to all the users, groups and others. So normally I would have done this chmod and then ugo plus and then rwx and then testing.txt. Usually I would have done this, but this time what I'm going to do is I'm going to do a chmod and then plus 777 and then testing.txt, right? So as simple as that. Now when I do this and when I press enter and then I do a ls-l, I will see that again all the users group as well as any other user has all the permissions into this file. But the question is that I executed this command chmod plus 777 and then a file, right? So I executed this command, but this 7, right, this 7, any of these 7s are not mentioned anywhere. The readability is 4, the writability is 2 and the executability is 1. So how does it work, right? Now let's take a look, right? For let's say if you talk about in the same command we talk about the user, yeah. So the first 7 that is there, this is for any user, right? This is for any group and this is for any other, right? So user is represented by a 7, I know, right? Group is represented again by a 7 and others are again represented by a 7, right? So this 7 where it comes from, it simply comes from the combination of 4 plus 2 plus 1, which means read, write, execute, right? Similarly this 7 comes from 4 plus 2 plus 1 and this 7 comes from 4 plus 2 plus 1, right? And I could have easily stripped off these permissions. I could have said that chmod minus 777 and then testing.txt. If I would have done this and do again ls-l, the minus is to remove permissions, right? So I'm taking off the permissions and this time I can see that none of the user group or others have any sort of permission on this file, right? And if let's say I again do chmod plus 777, right, and I know that my file has all the permissions for all the user. If let's say this time I do a chmod of 000, right, without any plus, without any minus, right, I press enter, what would have happened? Just think about it. Pause this video, try to think about it. If I do a ls-l and I press enter, I can see that again all the permissions have been stripped off, right? So I can directly set permissions without any plus or minus as well. I could have done a 755. Now what will this 755 give me? If you have a pen or a paper with you, try to write down what this 755 would give me in this case. Like what would be this 10-bit permission for this file after I execute this command. According to me, it should be -rwx and then it should be r-x and then it should be r-x, right? So the writability, the writing permission from the group and the others would have been stripped off, right? If I press enter and I do a ls-l, I can see that my writing permission has been stripped off from the groups and the users. And now you may be wondering that 5 is also not there. So let's just for our peace of mind, let's just map all the numbers. So let's say that from 0 to 7 we have all these numbers, right? We have 0 and 1, 1, 2, 3, 4, 5, 6 and 7, right? So 0 means no permission. 1 means what? Executable, right? 2 means write. 3 means what? Write plus execute. 4 means what? Read. 5 would mean what? Read plus execute. 6 would mean what? Read plus write. And 7, as we already know, is simply read plus write plus execute. So this 0 to 7 is covering all the possible combinations that I might need for the permissions. That's why these read, write and execute are like numerically represented by 4, 2 and 1, because from 0 to 7 they are covering all the possible scenarios of all the types of permissions I might be wanting to give to any file or any directory, right? And when we write it in this numerical value, the first digit is always represented for the user, the second digit is always represented for the group, and the third digit is always represented by for any other user, right? So that's how it usually works. Now let's take another example for this, like just to quickly show you. We were talking about /etc/shadow file, right? So let's try to do a ls-l on that, right? I do a ls-l and then /etc/shadow, right? I press enter. I can see that this file right here belongs to the root user, right? It belongs to the root user, and I can see that it has the read and write ability for the root itself. Now the shadow user can read it, shadow group can read it, but any other user including myself, because I am not the owner of this file, so any other user, I come under that, Apoorv Goyal comes under that. Any other user can neither read this, neither write to this, neither execute this, right? So that is the reason when I try to do cat on this, I get a permission denied, because I don't have the reading ability, like the reading permission for this file. Only the root and the its group has the reading permission. Right. Now I could have simply done a sudo chmod, right? And sudo, because since it belongs to the root, I need the sudo, right? So I do a sudo chmod, and since it has read and write, then the first digit is 6, the second digit is 4, and I want to give a 4 again, like the readability access to any other user, right? And then I do this file like /etc/shadow, right? I press enter, it asks me for my password, I do enter. Now if I do cat /etc/shadow, I would be able to read this file, right? And I'll again change back the permissions, because I don't want to change it, right? And with just the example I showed you, you can see that even the files that contain sensitive data, you can change its permission to access that data, right? So just due to this reason, chmod is not usually recommended to use, since you might end up exposing some sensitive data to some other users that you otherwise did not want it to expose. So for the sake of those scenarios, it's better not to use chmod command, but sometimes it does comes in handy. So just to give you an example, when we usually work with AWS and create an EC2 machine, then for that EC2 machine we generally get a .pem file, and that .pem file is used to do a simple SSH to just access the server, to just access the server and do whatever you want inside that server, right? So when we get that pem file, we first have to change the permissions of that file, or like before we can even use it to SSH into our remote server, right? So in those cases, and that's just one example, right? Later on when we'll be talking about the AWS Masterclass, then we'll be getting into a much more detail about all of that stuff. But yeah, I mean, usually it's important that you don't use this command, but sometimes it does comes in handy, right? Just just like the example that I showed you. And why you should not use it, again I showed you an example for that. The etc/etc/shadow file, it contains sensitive data regarding my system, and I just showed you how I exposed it to any user in the system, right? Which generally gives me a permission denied if I try to access it, right? So all of that is there, and be mindful of that. Now moving forward, you can also change the ownership of any particular file or a directory. The command is simple. You simply do a sudo and then chown, right? And then you give the name of the user, whatever it is, username, and then you just write the name of the file. This will simply change the ownership of the testing.txt from Apoorv Goyal to username, or whatever you add, like whatever other user exists, right? And you can also change the group of a particular file. You simply have to do chgrp, which is change group. Chown was change owner, chgrp is change group, right? And you give the name of a group, and this will simply change the group of the file testing.txt. And if you want to, let's say, simultaneously change both the owner as well as the group, then you simply do a sudo chown, and you write the name of the user, colon, and then name of the group, and then testing.txt. So this will like change the owner of the testing.txt to username, and change the group of the testing.txt to user group, right? Or the group name it should have been. Apologies for that, right? So these are generally two basic commands, chown and chgrp, right? To change the ownership or the group of a particular file, because many a times you might want to give access to of a file to another person. As a sysadmin, it is important, because you might be changing accesses here and there, so it's better to just give the ownership to someone else, whoever is responsible, right, for making some changes to that file, right? So that you can do. Now all the files that we create, let's say I remove the testing.txt and I create a similar file testing.txt, and I also create a directory called sample, right? And I do a ls-l, right here. Then I can see that my sample directory comes by default with these permissions, and my testing.txt file, which was created by default, comes with these permissions, right? So sometimes you might want to change some permissions, some default permissions. You might want to assign some other default permissions rather than what is usually gets created by default. So for that, what you can do is you can simply use a command known as umask, right? And after umask, you just simply give a number 777. But there's a catch here, right? So whenever we use the umask command, let's say I do a umask and I do a 022, for example, right? So what it will do is, the maximum permissions that any file or directory can have numerically is 777. So this umask, what it does is, it kind of subtracts the number that you enter here. It will subtract 022 from here, which will give you 5, 5 and 7, right? So this would be the default permissions that you will give after running this command, right? These are the default permissions. It's not like that your default permissions would be 022. Your default permissions would now be 755, right? So whenever you, if ever you use the umask command, then do make sure of this thing. And that was pretty much it for the umask command. Now there is another thing known as setuid, right? So there is another thing known as setuid, or the SUID. And many a times it might be a situation that you need access to some file, right? But you don't have the system admin with you all the time, right? So whenever you, let's say, try to sudo something, then it needs a password, and you will have to look for system admin. Bro, come here, enter the password and things like that. And you can't always rely on the system administrator for these kind of things. So, and you do need the access to some files that might be using some other permissions that you don't have access to do some stuff. So there this set UID or set user ID comes into picture because it lets you do something as the owner rather than being yourself, right? So I know it is a little bit complicated to understand, but let me give you an example, right? So earlier we saw a command called passwd, which is simply to change a password of any user, right? If I, let's say, enter passwd, I press enter, it will ask me for my current password for the user Apoorv Goyal, right? I can write my current password. It asks me for a new password. I can write my new password. Although I don't want to change my password, so it's saying that the password is same as the old one. What I'm going to do is I'm going to simply close this terminal, open a new one, right? So we know that a simple passwd command lets you change the password, right? And earlier in this video we discussed that all the passwords that are there, they are generally stored where? They're generally stored in /etc/shadow file, right? We check the /etc/password file, passwd file, and there the x means that the password is encryptedly stored in /etc/shadow file, right? So let's check the permissions of /etc/shadow, right? So I do an ls -l, and we just checked it earlier, right? And I do this and I see that this file belongs to the root, right? So I'm trying to run a command. I'm running a command called passwd, which is eventually going to make changes in a file that belongs to the root user. So how am I able to do this? Because I don't have root privileges, right? But still I am able to access that command, which is going to change a file that belongs to the root user. And it is going to do that you know without me having to write the sudo command, or without me having to get enter some password, the system password through some sysadmin or whatever, right? So how am I able to do that? Now in the previous video when we were talking about environment variables, I told you about an environment variable called path, and this environment variable path usually contains all the paths that your Linux would search whenever you try to execute a command or do something, right? So there was one particular path, if you remember, which was known as /etc /usr/bin/user/bin, and inside of it I have the command passwd, which I'm trying to run. So let's check the permissions of that, right? I press enter. I again see that this command belongs to the root user, so I cannot run it without being a user, and it also belongs to the group root, right? And that is there, but still, I mean, how am I able to run this? When I don't have the root access, how am I able to execute it in the first place, right? So the answer to this is pretty simple. Here, if you look closely in the user's permission bits, you will see that the third bit that is there, instead of being an X, this is an S, right? So this S that is there in the user bit, or what I'll do is I'll just quickly copy this and paste it here, right? So this are the these are the permissions of my /user/bin/password, right? And it contains an S. This S usually stands for what? It stands for SUID, right? Now what this S means is that this S, whoever is going to access this command, or whoever is going to try to launch this process or this command, is going to automatically have the permission of its owner and the execution permission. So when I try to run this command, just because there is this S mentioned in the executable, like the execution permission of the user of the um second to fourth bit, just because it has an S here, it means that whenever any other user tries to run this command, right, they are going to automatically have the permissions of the users to run this command, and also have the permissions to execute it, right? So that is what generally this S means, and that is how setuid can help you avoid using sudo for particular things that you might be needing regularly. So whoever launched this program is automatically going to get the owner's permissions as well as execution permissions. And there are two types of S, right? So one is a small s and the other one is a capital S, right? So the small s gives you owner permission, and execution. The capital S only gives you the owner permission. You still cannot execute this file, right? So capital S is a little bit rare, but just for the sake of knowing, you should know it, right? Usually it's just the small s, right? But I'll show you an example of the capital S as well, right? For now, let's try to understand how we will be able to add these permissions, right? So to add these permissions, it's simple. There are two ways of doing it. The first way of doing it is simply writing the sudo chmod u plus s and then file. The second way of doing it is simply sudo chmod and then 4755 and then the file, right? So this 4 before the usual permissions that we give denotes what? It simply denotes the SUID. So that's how it usually is. And to give you an example, again in my bootcamp folder, I have a testing.txt, right? I simply do a sudo chmod and then 4755, right? And then the testing.txt, I press enter. It asks me for password, I enter the password, and then I do an ls-l. I press enter. I can see that this right here has granted me the access, right? Currently it has given me the S access as a user. So any other user who will try to now run this testing.txt is actually not a command, but if let's say it was an executable file, maybe a Python program or something like that, that could be executed, right? And if let's say some other user try to execute it, then they would automatically have the permission of the owner, which in this case is Apoorv Goyal, right? And in previous case we were getting the permissions of the passwd's owner, which was root, right? And we are getting the permissions to execute that file, right, since it is a small s, right? But if I do the same thing on a directory, let's say the directory is sample, sorry, not dot, sample, right? I press an enter, I do an ls-l, and just to sorry, so I do a 655 and a 4, right? So I'm not giving the execution permission, and now I do a ls-l. I am saying that they are going to have the owner's permission, but they still cannot execute it. Why? Because I entered a 6 here, 655, right? And 6 means that I am giving the read permission, I am giving the write permission. 4 means I am giving the set UID permission, right? Like giving any other user the permission of the that the owner of this directory has, right? So this time I'm seeing a capital S because it will automatically get the permissions of the owner, but it will still not get the permissions to execute this file, right? So that is there. And very similar to SUID, we have a set UID, we have a set GID as well, right? And as you might already be getting, it is pretty simple. SGID, right? It is pretty simple. It simply, does the same thing but for groups instead of users, right? And this same thing that would have been there, I could I can simply add an S in the place of X that should be there for the groups, right? So to give you an example, I can simply, and if I, let's say, wanted to change the group permissions of a file, then I again have two ways to do that. I can simply do sudo just like above, and then chmod, right? But instead of u, I do a g plus s and the file, or I can do a sudo, again a chmod, and this time I can do a 2755, right? And then the file, right? So if I, let's say, execute this command here, I do a sudo chmod and then 2755 and then testing.txt. I press enter and do an ls-l. Then I would see that this s is now here, right? So the group this time has the permission, right? If I do a 4755, I can see that my user has the permission of the SUID, but if I do a 2755, I can see that my group has the SGID permission, right? Same thing applies to here, that whatever, a user from whatever group tries to access this file now will automatically has the permission of the owner groups. Right. So the owner group in this case is again Apoorv Goyal. Apoorv Goyal is the name of the group as well. So if, let's say, some other group tries to access this file, they would automatically get the permissions of the Apoorv Goyal group. Right. Just for this file. Right. And again it has the concept of capital S as well. If I would have here done 745 and pressed enter, then I can see that instead of a small s, I have a capital S, right? Which means that I can still not execute it because 4 is just for read, it does not gives the execution permission, right? So it's basic stuff once you get the hang of it. And there is an inbuilt example of this group thing as well, which is ls-l and then slash user slash bin, and there is a command known as wall. I press enter, I can see that for this the user has the read, write and execution permission. The group has only read and the SGID permission, and then any other user would have the read as well as execution permission but not the writing permission, right? It belongs to the root user and the TTY group. TTY is simply teletype, a fancy word, but it's usually just the shell and the or the terminal, right? So shell or terminal is also known as TTY, which whose full form is teletype, right? So that is there. Now there is a third type of permission known as the sticky bit permission, and this is like, I find it quite interesting, right? So the sticky bit one, and the sticky bit permission, what it does is that it will give you all the access. Like it will give you the you can read, you can write, you can modify, you can do whatever you want to do, but only the owner can delete it, Right, so if a file or a directory has the sticky bit permission, only the owner would be able to delete that file. No one else can delete the file. Everyone else can do whatever they want to do. They can read it, they can write it, they can modify it, right? They can do whatever they want, but they cannot delete it. Only the owner has the access or the permission to delete the file. That is known as the sticky bit permission, right? So again, just to give you an example, uh, there is a directory known as /tmp, which stands for temporary, right? So I'll do an -ls and then -l and then a /tmp. I press enter here and I see, all the contents inside of it, but I actually, did not want to see the permissions of the contents inside of that folder, or I actually wanted to see the permissions of that directory itself, right? So in the above command only, what I can do is I can simply add a d, right? So ls hyphen ld, d stands for directory, and then /tmp. This will give me the permissions of the directory itself, right? So I got the permissions of the directory, and here in this string, do you find anything weird, like something that you have not seen before? There's a T, right? At the very end of it, there is a T. This T is the sticky bit, right? So it is denoted by a T, right? And you can simply, do sudo and then chmod, and I think a +T directly would work, and then you do whatever the directory it is. It usually works on the directory. File 2, I like haven't seen an example of a file, but might work on a file. I can try that. The second way of doing it is sudo and chmod and then 1755 and then directory or file, whatever it is, right? This one, as you might know, like have guessed, is the sticky bit permission, right? So again, earlier, I mean, we talked about how 4 is denoted by readability and 2 is denoted by the writability and 1 is denoted by the executability. But when they are prepended to the permission that you want to give, then they have different meanings. So when you prepend it to the permissions, right, that you want to give to a file, this 4 then becomes SUID, the setuid. This 2 becomes the setgid, SGID, and this 1 becomes the sticky bit, right? So that's how it usually works. And now if I, let's say, try to change the permissions here, chmod and sorry, sudo chmod and then 1755 to the testing.txt, and if I do a ls hyphen l, I can see that the T has been added. So this time anyone can do whatever they want to do with this file, but no one can delete this file, right? So I guess still the sudo can delete it because it's the super user for a reason. Yeah, so super user can still delete it, but any other user won't be able to delete it, right? So that is there. Now I'm not going to try to show you to delete the /temporary folder, because as I mentioned, any wrong move and it's going to mess up the entire operating system, right? So it's better not to play along those lines. But sometimes if you need it, and if let's say you have multiple users in your system, then this is going to come in handy, right? Now there is one more thing that I would like to discuss, and that one last thing is the process permissions, right? The process permissions. So let's say we have, let's say, two users in our system, right? The first user is Apoorv and the second user is Kunal, right? So we have these two users in the system. Now let's say that I'm currently logged in as Apoorv, or let's say that Apoorv, has a UID of 600, and let's say Kunal has a UID of 500. We already know that we have a root user in the system, right? Its UID is what? Its UID is 0. We talked about it, right? So let's say I have two users in my system, Apoorv and Kunal. Apoorv has a UID of 600, Kunal has a UID of 500, and root is like the default user that is already there, the most powerful user, and it has a UID of 0, right? Now let's say that I have logged in into the system as Apoorv, right? And we already saw how we can execute the passwd command. So I execute the passwd, right? And then I write the name of Kunal. So what I'm trying to do is I'm trying to change of the password of some other user, and the name of that user is Kunal. So I have two questions for you, right? The first question is, will this work? It's a very simple question. Will this thing work? If let's say as Apoorv, I'm trying to change the password of Kunal, and I already saw that I can access the passwd command without being a root user. Why? Because of the SUID, the setuid function the command that we just talked about, right? The permission bit of the SUID, right? So I know that I can access the passwd command. Now can I change the password of some other user? I can change my password, that is very clear, but can I change the password of some other user? Just think about it. Pause this video, think about it. Well, the answer is pretty simple. They don't say Linux is the most secure system just like that, right? You can't do that, right? I cannot change the password of Kunal just by typing this command as Apoorv, just because I have some, added privileges due to the S permission bit, right? So I cannot do that. But now the question is why? Why won't I be able to do this? Why would this not work? Again, pause this video, try to think about it. Again, the answer is pretty simple, right? Whenever we, try to execute any command, what is it? Whenever we try to execute any command, it is a process, right? And, whatever things that, run in Linux, they are usually processes, and these processes are usually associated by three user IDs at the same time, right? So they are associated by three user IDs. The first user ID is called the effective UID. The second user ID is called the real user ID. And the third UID is called the saved user ID. Right. Now, effective user ID is generally the user ID of the owner. Right. So in this case, if I'm running the passwd command, and we know that the passwd command belongs to the root, so what will be the effective UID? 0. It is 0. Right. Now the real UID. Real UID is the UID, the user ID of the person who has launched this process. So I am the one who launched this process. What will be the real user ID in this case? It will be 600. Right. Now, when this process will try to execute what I implemented, it will say that Kunal's user ID is 500, right? But the person who is running this command, his user ID is 600. So should I allow this? No, I should not allow this, and it will not let you do it. Right. Now you might be wondering what is the safe UID. This safe UID, saved UID is pretty simple. It just lets the process switch back between the effective user ID and the real user ID, right? Because whenever you run a process, you don't want the process to always run on you know higher privileges or better permissions, because then it might end up messing the system. So you only wanted to use higher permissions only when it is required, right? So when I run the passwd command, it will run on the effective uid instead of the real user id, but most of the times it generally runs on the real user id only. And it just helps, saved uid just kind of helps the system to activate the effective uid, and in the meanwhile save the real user id into it. If it, let's say, activates the real uid, then it will save the effective uid into it, right? That's how it, like, it's just like a thing to maintain the variable, like what is the uid that it is saving at that time, and the other one it is just using simply, right? So that's how it usually works whenever you start your system, right? In most of the cases, the effective uid and the real uid are same, right? Because this s permission is not that common in the system, right? So most of the times the effective uid is going to be the person, the uid of the person who owns the the thing. And most of the times you would be only running the things that you own, sort of own, right? So most of the times the effective uid and the real uid are going to be same, right? When you start your system, when you enter your password, the system sets the effective uid and the real uid for you, and they both are usually your user id only, right? So that's how it is. And again, coming back to the question, when we say that why the passwd kunal command would not work if executed as Apoorv, the answer is simple. Kunal's user id is 500, and although the effective user id with which the process is working with is 0, right? Just because my real user id, the person who launched this process, just because my real user id is 600, it will say that this 600 is not matching with 500, and thus I would not let this happen, right? So it will strictly deny that. But if I would have done that as a user, then it would have let me do that, because user is very powerful. Like, the root user is very powerful, right? The root user can bypass anything in the system. It's like the godfather, right? So with that being said, I think that's pretty much it for this video. In this video, we've been talking a lot about processes. Oftentimes you must have heard about process. Even at the beginning of this video, I mentioned processes. So if you're someone who are wondering what processes are and things like that, then don't worry a lot about it, because in the next video we are going to only talk about processes and some packages as well, before we dive into the Linux internals, like how Linux works internally. But and by this point of time, you might be having a very good idea of how things work. You might be getting a lot of clarity of how the entire operating system works behind the scenes and things like that. So if that is the case, then I'm more than happy for you guys, that I'm able to teach well. Don't forget the learn in public initiative. If you feel that you've learned anything valuable in this video or any of the previous videos of this bootcamp, then do make sure to write a nice blog about it, write a nice Twitter thread about it, and post it on Twitter by using the hashtag that you see above, hashtag learning with Apoorv, right? And also in my virtual tech schools website, the community website that I have, if you haven't joined the Discord server yet, then do make sure to join the Discord server. The link to that would be in the description below. And in the website of virtual tech school, I would be having some additional resources for all the videos that I'm creating as well. And these additional resources are also going to include some Twitter threads as well as some blogs as well. So I usually want to, pick up some threads and blogs from the, from what I've been receiving from you guys. So I encourage you to write some good blogs, to write some, good Twitter threads, pass it back to the community so that, if I really like your threads and blogs, I'm going to include those threads and blogs in my website as well, so that way you are going to get a lot of reach as well on in those blogs and threads. And only going to pick a handful of blogs and threads that are really good, that I'm going to include in that website. So spend a couple of time, like spend some time, a couple of hours to draft a nice thread or a great blog, and share it with me on Twitter. Tag me in those tweets when you're sharing it, and use the hashtag learning with Apoorv, because whatever filtering I'll be doing for any of these threads and blogs, I would only be searching hashtag learning with Apoorv on Twitter, and based on that I would be seeing what all blogs and threads have been created by you guys. So whatever blogs and threads I generally like, I am going to include them in my website next to the link of these videos. So you're going to get some traction on that. And we have already discussed how these Twitter threads and blogs are going to help you and learn in public, help create more opportunities for you, and how they are going to add up nicely in your portfolios as well as your resumes, right? So it's a win-win situation, right? And you will get to pay back to the community I'm trying to build. So I would be very thankful to you guys if that turns out well, right? And yeah, I think that's pretty much it for this video. Hashtag learning with Apoorv, right? And I'll see you in the next one. Till then, bye.